Hi dear students, let's see this question that came in JEE Advance in the paper 1 physics in the year 2019. This question was from the topic of Young's modulus, properties of matter, and this was a simple question, and I'm sure that most of the students would have collected free marks in this. So here we have a steel wire and a copper wire. The lengths have been given. Cross-sectional area have been assumed to be same. So we hung a block whose mass or weight 100 Newton has been given, and we have to find the ratio of the elongation in the copper wire to the steel wire. This is what we are assumed to we have to find. So let's see like how do we do this question. If we balance the forces on this point, so 1 mg is going to act over here. Let's say the tension in the copper wire will be Tc and tension in the steel wire is Ts. Now this angle we can say will be 150 degrees because this will be 60 alternate angles, so this will be 90, so total will be 150. Similarly, this angle will be 120 degrees and this is 90. Now if you apply Lami's theorem on this point, so we can say that Ts upon 120 will be equals to Tc upon 150, sorry, sine of 120. Ts upon sine of 120 will be equals to Tc upon sine of 150 is equals to mg upon sine 90. Although we don't need this thing, but I wrote it just for the completion sake. So from here we can say that sine 120 is sine 60 as well. So we can say that it is root 3 by 2. So this will become like this. And sine 150 is half because it is sine 30 as well. So this will become like this. So from here 2 and 2 will be cancelled. So we can say that Tc upon Ts will be equals to 1 upon root 3. Right. Now, if you apply the Young's modulus formula on this, stress by strain equals to Young's modulus. So if you see the copper wire, so we can say that Tc upon area of cross section will be equals to Young's modulus of copper into delta LC divided by length of the copper wire, which is root 3. Okay, and Ts upon area of cross section, which is same, is equals to Young's modulus of steel into delta L of steel. Delta L of steel, which we have to actually write it over here to find the ratio, and length is 1. Now if you take Tc by Ts, just divide. This is, let's say, equation 1 and this is equation 2. So if you divide equation 1 by equation 2, you're going to get Tc by Ts, okay, which is nothing but 1 by root 3 is equals to uh, Yc into delta Lc divided by root 3 into Ys delta Ls, right? Root 3 and root 3 will be gone. So we can say that delta Lc upon delta Ls, that is what we need to find, delta Lc upon delta Ls, yes. So delta Lc upon delta Ls will be equals to Ys upon Yc. Now what is Ys? Ys is this and Yc is this. That means if you take the ratio, you can see that this will be cancelled. So we are going to get the answer as 2. This will be the answer. So as you can see, this was a fairly simple question and almost all the students would have done this under 2 minutes in the exam. Thank you.